So I dive into the world of AI, the second event, the data cleaning. Today we're just going to go over a recap of what we did a few weeks ago with the data collection and the introduction. Then we're going to go again over the pipeline of data pre-processing itself. Now this time it's not the pipeline of the whole algorithm, but just like focusing on what's the pre-processing part. And then we're going to go into a detail on how to upload your data to a platform that you can use. We're going to recommend Google Colab for now because we're the Google Developer Steering Club, and because it's very efficient, very powerful, and works a lot, can allow contributions, allow for you to share your code, allow for you to share your notebook, allows for really powerful algorithms to work on it seamlessly, and it has a lot of potential, and you'll be using it a lot. It's very efficient. Even if you don't have a great computer, it can help you avoid that problem. It's not the best, of course, for everything. You sometimes need a more advanced computer when it gets to the harder algorithms or the more complex algorithms, but a Colab is good for what we're going to take today and for the next 2 weeks. Let me check. Yeah, so after that, we're going to go over the data cleaning itself, which is the bulk of the project itself. And in the data cleaning, we will also go over how to get your data itself and what are the most problematic aspects of data cleaning. What is the problems when you get to have your data and you want to run it through an algorithm? And after that, we're going to go through the missing data, which is one of the most problematic parts of, in general, in data altogether. Data and data mining and data warehousing and databases, the missing data is a huge problem, especially data analysis later on, when the whole model thing is just data analysis, automatic data analysis, basically. And then we go over the data encoding, which is taking data and just transforming it to be acceptable for the model later on. So let's start with a recap of the last event. What is AI and machine learning? We went over what is AI and the machine learning idea, that it's the most popular method of machine learning, which takes data, runs it through a mathematical algorithm, and then gives us back a result or a prediction, classification, a regression, whatever. The pipeline of the AI, which is this one, we go with data collection. We saw it before. Data pre-processing, a very important step. Splitting the data if necessary. And then the model selection, which model you want to use for the analysis. The training of that model, you train it. This is something that's done for a few hours, a few minutes, depending on your computer, depending on the data, depending on the model. And then the evaluation, and then you go back to data pre-processing or model selection, and so on, and then the deployment. So yeah, some more people are joining. Yeah, and so today we're going to focus back to our most important part, or one of the most important aspects of the machine learning pipeline, which is the data pre-processing. For the data pre-processing, we already covered the data collection part. So today we have to cover the second step, which is data collection. This might seem like it's a lot of, if we're going to go for each point of the data pipeline of data pre-processing, we're going to take I don't know how many events to just cover it all. But in general, data cleaning is very important. It's a very important, essential step when you come to trying to deal with your data for machine learning. And it covers more than the data, data cleaning itself. Will cover a bunch of different steps that can help you later on with the data transformation and feature engineering and so on. Then it comes to data transformation, feature engineering, and handling imbalances. This will all be covered all together in the next event, most likely, which should happen next week, hopefully. So to start with, now let's get more practical on how to upload your data to your platform, okay? Not the platform that's like Python, that you will use Python through. So as we said, we want to use Google Colab. Google Colab, let me see if I can start with Google Colab. Yeah, Google Colab is the main platform you will use. It's cloud-based, so whatever you will run on your computer, it's going to send it to a server owned by Google, which is going to run your code, your Python code on it, and then sends you back the results, which is efficient when you don't want to harm your computer if you were doing something extensive that takes time but doesn't need so much computing. It uses some advanced GPUs, but still, if you want the best GPUs, you need to pay for them, and it's different, it's complicated, but it's very efficient, very useful for these smaller models that we use, or the medium-sized models that we will use, and it's really good for learning. It's efficient, it's fast, it's quick, and it has some problems, some few problems. One of the problems that I face with it is that uploading the data can be a little bit challenging because it's not similar to when you're using PyCharm, you're using Jupyter Notebook on your computer, where just the data, it's the same file or the same path. Here you need to upload your Google Drive, or this is one of the methods. You can upload your Google Drive or a drive in general on GitHub and so on. But Google Drive is a method that's nice to keep it private and to keep your data secure. And then we're going to go through pandas, which is a library from Python that can go through CSV files or Excel files and can actually read the data of the Excel file very well, very efficiently, and allows you to apply your Python code on that Excel file. Then scikit-learn, which is one of the most important tools in machine learning altogether. It has most of the algorithms, it applies most of the math, and it uses pretty much basic libraries like NumPy and SciPy to do the math for you for the algorithms. It's very useful. It's going to be very essential, and we're going to see it almost today in every single step of the work we're doing. We're going to find scikit-learn and pandas. The data source, we would use the Kaggle from last event. This is for tomorrow. The data source, either you find your Kaggle data set that matches what we mentioned last in the last event, or we're just going to find the sample data for you, which we use and we showed last time. So for this event, I'm just going to show the sample, which is the same sample we used last time of the space missions. And we're going to go over it again. So for Google Colab, and we're going to find it's online, it's cloud-based, as I said. It's free if you want to use the free version of it, which doesn't have much RAM. It has enough RAM to run most of the stuff that you need. But when you want to get above that RAM, which is, I believe, is 12 gigabytes, when you want to get above that, you need to pay more for it. I believe $10 for $10 or $11 for the computing, the 100 computing units. 100 computing, it's an interesting system which says if you're using a lot of computations, then you use more of your computing units. That's more complicated. We're going to get to that much later. But how to access it, you can find the link here. I added this to the slides. I'm going to post the slides after the event. And you go through it to the link. You can just Google Colab, and you will find it. And you start your own notebook, okay? You open a new notebook, and from there, you will get this page, an empty canvas where you start writing your code over there. In this line, you will just write your normal code. It's different than when you have a whole Python page where you can just write the code and it runs everything. It's like a notebook here, so it just runs blocks of code at a time, which is useful for machine learning, especially when some computations take a lot of time and some others don't. So you don't want to run the whole code again when you're just fixing a small thing, like you're changing the model, you're changing a small certain thing. You don't want to change the whole thing. So you just want to change that block and rerun that block. So this is useful here, where you can just run these tiny blocks. It can save you time, saves you energy, and makes it cleaner and more neat, especially that you can add text in between to add like sections of the code. This is data pre-processing, this is the machine learning model, this is the results and the analysis of the results, and so on. So the second tool that you will use for uploading the data is the Google Drive. Your Google Drive, I believe everyone uses their Google Drive here. And the way you can do it is that you upload your data there in the Google Drive. And then after that, you will mount your Google Drive to your notebook, which is a system where you can tell the Google Drive to tell Google Colab, to take that Google Drive, your Google Drive from your account. It logs in, takes it down there, it gets your whole drive on the Colab notebook, and then you find the specific file you need through that Google Drive. After that, after you're done with everything, you unmount it, which is important in general when you're doing this stuff so that you don't corrupt any files or anything by mistake. But you're going to get to that. You're going to see the code now. All right. So to start with, before you do that, if you're going to use Kaggle, like we will, you will go to Kaggle itself, download your data, and downloading data, you need an account on Kaggle, and after you download it, it's going to be downloaded as a zip file. When you download the zip file, you will take it, unzip it on your computer, then just upload it. I believe this is just familiar to everyone, but in case you need to know it, you will go to your Google Drive new and then upload a new file. After that, you will go back to your Colab and write your first code there. The first code is just going to be a small line saying from the Google Colab, it's a library, it just import your drive. And then you're going to ask it to mount the drive. It will ask you to sign in to your account. Usually that's safe. And then you will just mount your data there. This is, again, it's some vital stuff. Then you will import pandas, which is where now you locate your drive, you locate your file, and from there you can actually get your data itself. So you're going to go through pandas, importing pandas. Pandas is the library that we're going to use for the Excel or the CSV files. And then you're going to go and write the specific path, which is, as you can see here. If you want to try alongside, we're going to, as I said, we're going to just try tomorrow well in a lab, and we can actually just show the code as we move on. Here I'm just showing the snippets of the code. And then you will encode it as Latin because it helps removing some of the issues with the encoding. Not important detail, but it's useful to know when you face a lot of errors, because there will be a lot of errors, especially when just a weird file and not every file that you will find, especially online, is perfect when you want to analyze it. After that, you will get your data just by putting data df, which is the name of the data frame, which you give it here. Can you see my mouse though when I move it? Well, if you can see my mouse, you can see that I'm just pointing to the data frame here. This is just the name you give to the whole data frame or the data set that you want to see. As soon as you do this, Google Colab automatically knows how to deal with the data, how to arrange it for you, how to show it to you. And this is a way that it shows it the company, the location, the date, and everything, well structured, just a sample of the data of most of the columns, if that's allowed. Like if it's too many columns, then it just shortens them a little bit. If it's too many rows, as you can see here, we have 4,600 rows. So it shows the first 5 rows and the last five rows. So it shows them all with the 9 columns and shows just samples of them. So you can see here, this is this is the data set of the space missions. You can see the USSR, the company that did it, SpaceX in the last ones, but this is the first one. This is the very first ever space mission. It flew from Kazakhstan. That's the location, the date, 1957, and the time, and everything, all the information here. And then you can see also the new one, SpaceX, and so on. So this is a nice format to see the data. It's useful and helpful when you're trying to do some data analysis to see how your data looks like, because sometimes when you're downloading it from Kaggle, or if it's not even from Kaggle, if it's a different source where the data isn't really so visible, if it's a database or SQL or something, and you cannot really see it well enough on the platform they're using, it's ordered, it's nice, it's pretty here, so that you can just have a good idea and a good intuition how your data looks like, which is important for when you're doing the data analysis itself before any modeling. Now that we covered how to upload the data, I believe now you can see the data, everything is there. We can now jump into the data cleaning part, which is the big part of the event today. Data cleaning is that when we're focusing on the tabular data, like the data frame that we saw, we want to go over it, make sure that all of the data we have are just perfect enough and structured well enough for the model itself. Because the model, again, it's just doing math on matrices. So you need to have a big matrix. I believe the matrix, as you see, like we'll see it in linear algebra, or if you saw it already, it's just a matrix with a bunch of numbers. And you want to make sure that they're all numbers that are just in the format of a matrix with no missing values, because missing value doesn't count as 0 unless you force it to count as 0. It just counts as missing. It's a big issue. The encoding, duplicates, irrelevant data, it's a lot of issues you will always see whenever you're trying to do any modeling on a data set. So the important part, which you start with, and this might be the most, let's say, one of the most essential aspects of the whole issue of data analysis or cleaning the data beforehand doing anything, the processing, is dealing with missing data. Missing data are pretty much just like a lurking issue that's always there. Most of the time it's going to be there. And there are different ways to deal with them. So the first thing you need to do is you need to spot them, because when you start a data set, as I showed you, you just see 10 samples of the data set, and the data can have millions and millions of rows or thousands of rows. But what you need is just, you only see 10 rows and that's it. 10 rows usually aren't enough to determine if there are any missing data or not. So what you need here is a tool that can help you show you where are the missing data, which columns are they in, which rows are they in, where are they most common, how can you deal with them. So to start with, we need just to pinpoint where they are, identify where they are. There are 2 common ways to do it. A mathematical normal way, which is just using pandas, and you gather the sum of all the missing data. This is the most basic and the most essential way to do it, because when you notice which columns have a lot of missing data, you know that this column usually, like let's say the price column, it's full of missing data. Out of 4,000 columns, we have 3,000 that are full of missing data. So it's a safe bet to assume that the price is not really going to affect a lot of the data analysis, because it's pretty much not available for any of them. So if you replace it with a different value, it's pointless. But it's good to know and find out that price has an issue. There are different methods as well of dealing with the missing data. Here we can notice that time has a bunch of missing data, but that's not so important because maybe it wasn't well recorded, maybe it was confidential information because this is about space missions. So it wasn't really mentioned there. Another way that you can see this is that if you find 2 columns with similar missing data. So let's say if we suddenly find missions with also 3,365 missing data, then what's the issue here? We can notice that there's a pattern of correlation between them. This you cannot see it well here, but there's another library called Missing No, which can help you with this idea. This is a small snippet of what Missing Go can do, and Missing No can do, and you can go through the documentation of Missing No. But there are other tools on it, other classes that can help you see the correlation between missing data. You can notice that there are specifically two columns that suspiciously have the same missing data. Maybe this means that these specific rows had issues, which if we look at it, let's say from here, from this side, you can notice that the missing rows are this one. So maybe the issue isn't really with the prices, or maybe the issue isn't with the time, but it was very specific missions where, let's say, the time was a secret, so they couldn't put it, and you make your own assumptions. But the analysis, of course, helps you with these assumptions that you can make. And based on that, you can know how to deal with the data later on. So identifying the missing data is one of the most essential ways, and depends on those two libraries. Pandas, Missing No. There are more libraries. Missing No isn't really I took it from my professor from the second year of machine learning, and it was very helpful. It has more. This is what we covered was the matrix for format, but it has more. There is a correlation matrix. There is more stuff to it that can help you later on when you're trying to figure out. Some other people are joining. Let me just do that. Yeah. So it can be very helpful when you want to do the data analysis on why something is missing. It's not just identifying them or finding them. It's also what they can do, what can you do with them, how you can deal with them, which takes us to the next step on how you can actually deal with them. There are a bunch of ways. One of them is just to delete all the rows with them. As I mentioned here, if we find a specific row that's a problem, that let's say the person who was filling out the data didn't fill it out that day well enough, or this data was secretive for this very specific row, so there isn't anything there, that is an issue. So a way we can do this is just remove that column, that row, instead of removing the column or assuming something about it, because it might be something out of the ordinary, something you don't know what could be instead of that missing spot. So this way, you can also use pandas just to remove that specific row in that specific column, like all the rows in that column. Or you can, of course, locate that specific row and remove that specific row. This might be like locating the specific row itself is a little bit time consuming, especially if you have thousands of rows. But if you want to find a column that has a lot of rows that are missing and they all seem to have the same pattern, which is, again, you can find it through the correlation matrix or through these stuff, then you can just drop these specific rows, like in this column, which we're using the drop an A, which is like null or not available data. So you just remove them all through this specific line of code, and it updates your data frame or database. This is the data frame, FYI, just like keep in mind. This is also always going to call it the data frame. You can call it data set. It's before that, it's data set. Now it's data frame. Okay, so just keep in mind whenever you see DF, it's data frame. So it updates the data frame, removes the missing data from the column time, and it then updates the whole data frame. You can also drop all of the missing data, and that just, you go over all of the missing data all over the place and just drop the rows with the drop now. Or you can drop the whole column. Like we saw here, the big problem was the price. The price has almost no data within it. It's pretty much useless. Even if we try to delete all the rows, then we end up with no rows at all. But because it will delete the whole thing, it's going to just delete one point. So the other way we can do it is just to remove the whole price column and just assume that doesn't exist, or don't add it to our calculations and assume it doesn't help. This might be an issue here where actually the price of a mission, like if you paid a lot of money, maybe the mission is more likely to succeed, but then it depends on the scenario. But here, if it's really this much of an issue, you can just remove it. You could remove the older missions where the price wasn't mentioned because it was a secretive mission, so there is really no point. And with the rest, you can try to do something else where you use an imputer. An imputer is pretty much something that guesses what can be in these empty places. There are some intelligent ways to do it, which is pretty much the first time now we will actually see AI. Or there are some of the more simple, basic mathematical ways to do it. We're going to get to use the scikit-learn library, which, again, as I told you, it's like the king of all libraries for machine learning, pretty much. And everyone uses it. Everyone will use it all the time. To start with, we're just going to go over the simple imputer, which is, as the name mentions, it's just pretty much simple. It's very basic. It goes over what is the mean, the median, the most frequent, or the constant, just adding a constant. So the mean, as the name suggests, it goes over the whole column, gets the mean of all the values in that column, and then inputs it in the missing data. The median, it goes over, again, all of the rows, gets the median, input it all over the missing data. and then the most frequent, it just goes and repeats it there. This might not be so helpful when we get to talk about numbers or a constant. Of course, just add a constant wherever it's empty. We can add a zero sometimes. That's helpful sometimes, if that's the actual case. But it's not helpful when you're doing regression, like guessing a price. That might not be helpful. But this is very, very helpful when you're trying to do something with limited numbers. Let's say you've got 5 numbers and you want to get the missing data is usually the mean, but you can guess that if you have enough data there and just a few missing data, you can guess that. Like in the time section, most likely than not, there's a certain time where most rockets launch, and then we can use these most frequent times and just input them, guessing that this could possibly be the case where this was actual time of the launching, or the mean, or the median, of course, or the constant where you don't want to add something there. So you just put the 0. If you just want it to be, let's say you want to assume that it doesn't exist, you just add 0. However, when we get to the more intelligent or smarter ways of doing it, we get to something, these are just, again, there are way more methods to do it, but these are some of the popular ones. So the iterative imputer, it goes over just a specific function from a different column, or it could be a similar column, but it goes through that function, and based on the function of a different column, it adds a value to the missing values of the column that you're targeting. I know this might be a little bit more complicated than before. It's just math again. It's pretty much, the idea is that you will go over the whole column. Let's say column 1 has missing data. Column 2 doesn't have any missing data. You will go and you notice that they're both similar or based on each other. You can take column 1 or column 2, do that function, add this function to estimate the missing values or the equivalent missing values of the other column, of column 1. All right? Then you have the KNN imputed, which means that, K nearest neighbor, which says that it will go over the missing point, it will check around the neighborhood of that missing point, and it will estimate the value based on the clusters of the nearest points. This is a method that we can call it the first AI that we see. It's very interesting. It goes through just a huge amount of missing data, gathers the information around it, and gives you a value based on what's around it or what's close enough to it or similar enough to it based on the surrounding information. It's useful. It's a bit heavy. It takes a little bit of time, but it's pretty useful. And then the missing indicator just turns the whole, this is, as we said before, this is pretty much kind of like transferring them all into zeros. Like if you have yes or no, that's it. When you have no missing data, it just adds yes. If you have missing data, it adds no, and stuff similar to that. It's not so important right now, and at least there are other ways to do it, which is using encoders, or you can just use it as well. It's also useful. But this is basically pretty much how to deal with the missing data. Either simple imputed, something easy and simple, not too much, or you try to be more clever about it and try to get something interesting from it. It depends really on your data, how the data looks like, how important it is for you to get the KNN imputer, because it's a bit heavier and it takes a little bit more time and more computation. So if you have 20,000 rows, maybe it would be, and the idea that how exact and specific you are isn't really so important in that specific column. Maybe you just use a simple imputed, put the median, the mean or something, and you can just fill it up. But if you have something smaller and you want to be accurate about it, the KNN imputed is somehow better than, it's not somehow, like it's a bit better than that. Now we get to the encoding part of the data. Before I continue, does anyone have any questions or anything? If not, so just continue the encoding part. Let me just take a sip of water for a second. So as we mentioned a little bit earlier, now the models that we use, they use mathematical algorithms. It's based on having a matrix, doing computation on this matrix. Or basically it's a big table, a lot of numbers, and all of these numbers, you try to do the math on these numbers. So this is pretty much important to not have words as your information in the table, but it's more important to have them all as, numbers, organized for them to fit into the model later on. This is important for us because, of course, when you have something like, let's go back to our data frame and try to use an example from there. We will notice when we look at our data frame that we don't even have not one column that has actual integers or numbers as is. All of them need some sort of encoding to be transformed into our data into our ideal data frame to be inputted into the AI model. So for encoding, we have to just find the type of column that we have and how we want to encode it. This is now where it gets actually more serious, and you have to be more analytical about the choices you make, and you have to understand your data well. Understanding data doesn't, of course, mean you have to understand everything in data, just the columns and the types of columns and how you can deal with these types of columns. Generally, it's more of a pattern. If like you find a certain thing in one column, you just can find it all over the rows in that column. But it's important to just keep that in mind all the time. So let's start with this idea of the nominal data. Nominal data, it's pretty much having data that doesn't have order, just a bunch of words, and these words can have a meaning. So the nominal data in our case here can go through. I want you guys to give me examples of what can be nominal data here. So nominal data does not have order. It's just a bunch of words that can have a meaning or no meaning of order. Okay. So let's say you have a certain column. I'm going to give an example, and then I want to hear your examples from this data, or you can just give me your examples from the data that you have, if you have one. For example, here we can go through the company. The company name, generally speaking, does not really have an order because, I mean, it's just the RVSN USSR, the US Navy, SpaceX, and so on. So there isn't really much of an order here, but it's just a bunch of information, a lot of them, and we need to transform them into numbers with no order, but just text into numbers. We will show a way to do this, which is the one-hot encoding. But before that, I want to see if you can spot more nominal data. If somebody would like to unmute themselves or just write in the chat. Let's see, just to give them, let's give a minute or two to see if anyone can just spot any of the nominal data that you can have here. Yeah, the rockets themselves, they don't really have an order. They're just a bunch of names of the rockets. Like you have the Sputnik rocket, the Vanguard rocket, Juno 1, and the Falcon 9. These are just names. They don't have really an order or any way of just identifying them that way. So what we can do for that is we use the one-hot encoder. If anyone has another example, feel free to share it before we move. All right, I'm assume that no. And so just a way we can deal with them is that we can make a one-hot encoder. A one-hot encoder basically says that we create a bunch of new columns. All of these new columns are now responsible for one of these words that we went over and will fill up 0 where that specific row is not from that company itself. Let me try to explain it better with an example. So, back to the data frame, the US Navy, it's one of the companies that we have. The new idea that we will do is that we will add a new column here called US Navy, or like it could be company US Navy, and it will go over every single row that has the US Navy within it. It will add a 1 there. Then it will add a 0 if it doesn't appear there. Sorry, you have a question? What if the names are so many, you end up making square data set? It will be a huge data set. Like I will show you tomorrow maybe on this specific data set on how we can one-hot encode the company. It will be a very, very huge data set with a lot of zeros and very little ones. This is called a sparse data set, which is not very useful because it can lead a lot of confusion, and you have a lot of zeros that affect the weights given later on. But it's also helpful for the idea that it can just give you a more organized way to see it, especially if you have few classes. So maybe at the end here, you can see that there's mission status, which has success and failure. If you have a lot of success and a lot of failure, this is just two new rows with a lot of ones and a lot of with little zeros. So yes, it makes huge data sets. I hope that everyone gets the idea of it. But basically, we say that we have the US Navy here. It will add 0, 0, 1, 0, 0, 0, 0, or 1, 1, 1 whenever it sees the US Navy. And then another one for SpaceX, another one for AMBA, another one for the USSR, another one for every single company we have, every single one of the companies that we have here. Each unique one has a new column. As I said here, the mission status, we just have new columns, success or failure, but that's not a big deal. So be careful how you do it, but there's a way to deal with it even if it gets large, which you'll see later on in the feature and dimensionality reduction, or how you can allow it's in the pipeline. In the handling balances, it's in the feature selection, technically. But it is not a great thing to do because it can actually lead to a very sparse data set, which even when you use these tools which can help against sparse data sets, it can also lead to confusion through the model itself. But nonetheless, it's an efficient way to deal with the column, the textual data, especially when you have certain classes, when you have specific classes or types that are apparent in the data frame. Another way to deal with this, which is different type of encoding, and it's more common when you have ordinal encoding, is as the name mentions, the ordinal encoder. The ordinal encoder, I don't want to take too long because we're getting technical, and if we stay for too long, then it just gets boring. I want to end like in 5 to 10 minutes. The ordinal encoder is about to be finished for today, and the ordinal encoder basically is saying that when we have a bunch of orders from, let's say, medium, large, small, medium, large, this can have some sort of order, giving small 0, medium number 1, and large number 2. It gives a nice encoding to the data that can help with just changing that value, for changing that number to a value. It is also helpful to do it with sometimes it's called the label encoder, not the ordinal encoder, for the data that you want to do as you said, as the one-hot encoding. This can lead to some problems or leads to bigger steps when you're doing something like neural networks. We're going to talk about that later. When you want to fixate the models, because it takes input as a large number. Let's say we go back to our data frame, and we want to say, where is the data frame? Yeah, I missed the data frame. Let me go back. So let's say we have the company, and the company itself, we want to make it as a label encoder or the ordinal encoder. So we give the USSR 0, 0, the US Navy 1, AMBA 2, and so on, okay? If we have, let's say, 300 companies here, the USSR is going to have the value 0, but that large company is going to have the value 500 or 300 if you have 300 companies. This can lead to problems with calculations because you're giving more weight, but then it readjusts the weight and so on. This also is not so ideal all the time because then you might have a problem with when you scale, unless you scale the data, it can be an issue with the more primitive models that cannot figure out weights well enough. But even like the most primitive, the most initial model, the perceptron, which we'll talk about later, it does figure out weights. But nonetheless, it's a bit tricky to do that, but it does help you in saving the space in your data and keeping the data just concise so you can read it. These are some of the two more important encoding methods, but there comes more encoders or more transformations that you can do to the data. These transformations can cover also something like, let me just go through it, which is called extra editing. This extra editing can go over something like the date here. The date, unfortunately, it's not a digit, it's not a number, but we might have more interest in the specific year that we have had the launch more than the day. I mean, the day doesn't matter. But if we're talking about the 1960s, more likely than not, it's going to be less successful because what we're trying to measure here is the mission success. The mission is not going to be as successful as if the mission was launched in the 2020s. Because you can see a lot of failures here, or at least 2 failures here, but no failures here because the technology got better. So maybe the year is very important for the analysis for the model later on. So what you want to do is just separate the date and the time and the date and the month, from that column and create a different column just for the year. because right now in its form right now, it cannot be inputted because it's not really a number. It's a kind of a string that has digits within. So you might have to do that anyway, but this way you can do it in a better way where you just get the only important information that you need. Fortunately for us, if this data is well and good, we have the the pandas library that can actually just cut the date and the year and gets us the year alone, and just we run a code through it all that can just get us the year itself throughout the whole code. Then the time, one of the things that when I was working on this data set, I thought maybe if a mission was launched in the day, it might have a different result than if it was launched at night. Maybe in the early days, of course, when let's say technology wasn't as good. So I cut the day into four halves, where there's a half, 4 quarters, where there's a quarter with the sunlight, quarter with less sunlight, quarter that's dark, and quarter that's in the dawn, let's say, and then there's medium sunlight. And that was an ordinally encoder because then you have no light, sunlight, and actual light. So that's a way that you can deal with the data, edit the data, then you do the encoder over it. I hope this makes sense. This is where it can get technical, and you need some data analysis and some intuition on what you're doing. But that's the idea of it. And that's editing the data itself. After editing the data, we go to finally the transformations that you can do, which can, that's basically here is that just you can create your own custom transformers, or without even custom transformers, just your own code that can run through a data set that can help you with just that. This mentions the year basically and how I managed to do the date. But these are some more analysis that you can do on the data set that can make it more efficient and better to input later within your data, within your model, I'm sorry. So I hope this covers most of the data cleaning for you, and hope it gives a clear idea. If it doesn't, tomorrow we have the workshop where we're actually going to do this manually together. We get your own data, get it ready for tomorrow, and try to join us, because I feel like some people aren't, like it's less years than last week, last event. But try to join us, because tomorrow we can take input, and it will not be recorded for tomorrow because it's just a practice session. And so I hope you join us and get your data ready. We're going to go over the data cleaning, and hopefully next week we'll go through the feature engineering. And we will be talking about the solution challenge soon, because we need to prepare our university team for the solution challenge and try to create our own project for it. So keep that in mind as well. We're going to have a whole session describing what it is, talking about it. And this is where we actually are at data cleaning right now. I hope you enjoyed the idea. It wasn't too much. I don't want to go too much into detail. And I didn't want to get extra topics, or it would have gotten more technical and would have been so boring. And we already covered 45 minutes, so I believe that should be more or less enough, or 30 minutes if we count the first 5 minutes, 10 minutes out. If you have any questions, please feel free to ask them here or the chat. Yeah. So if there are no questions, I believe you can end the meeting here, or the event here. Have a great day, guys, and see you tomorrow.